Good evening, everybody. I think all of you in a safe condition. Today, I will start my fourth chapter, that is effective stress. Before we know the effective stress, we want to know about the soil water condition in a groundwater surface. We all know that the main part or the soil is consist of voids and solid. For saturated soil, the voids fill with the water, and for dry soil the voids fill with the air. Now, in a normal condition, that's the voids are filled with water, air, and in a groundwater, we know that at a certain depth there is a layer of groundwater. That's why the soil rests in the voids in different phase. On the basis of retained in a voids of water, we can classify the soil in three parts. First, the broad classification, and the second one is the classification on a phenomenological basis, and the third is classification on structural basis. And in broad classification, there is free water, gravitational water. Second is held water, and held water is written in three parts. One is structural water, and is absorbed water, and is capillary water. And classification of phenomenological basis, there is a four types where the water retained, that is a groundwater, capillary water, absorbed water, and infiltrated water. And the third is the classification of structural basis, the water retained in four types. One is pore water, that is solvent water, absorbed water, and structural water. These all types the water retained in a soil. In my notes, I all covered all part. Please follow my notes. I already given in a Google Classroom. Now we will discuss that this part, that is the capillary water. Capillary water. Okay. This is a very important part in which the many physical properties of the soil. Suppose this chapter is effective stress. Effective stress is mainly affected on a basis of capillary water. We discuss what is capillary water and how we determine the height of the capillary water. Okay, let's see. Now, the capillary water. We know we know that the soil particle is consist of voids and the solid parts, and the main property of the soil is depends on the voids. Voids means this part, the voids means the soil particles are uneven. When it's rearranged, due to the unevenness, some kinds of hole will be appear in between three particle or in between two particle, and that is called the voids. Now we know at a certain depth we find a layer of water that is called the groundwater table. That is called the groundwater table. Now, before we discuss the capillary water, we need to know. Before we discuss the capillary water, we need to know about surface tension. What is surface tension? Surface tension, this term. What is surface tension? Surface tension is the property of the water. Surface tension is the property or the water property which exists a outer film of the water particle which exerts total volume in a minimum thickness of a spherical shape. Means this is solid particle. If we consider this a water particle, water, surface tension is a property of water which exists an outer film of the water particle which exerted the total volume of water in a minimum diameter of the spherical shape. Means due to the molecular attraction of the water, means the molecular attraction of the water, molecular attraction of the surface, and the molecular attraction of the water body, it's induced a tension force which contracted the volume of the water in a minimum thickness in a spherical shape. Now this is the surface tension. Means these all are the voids. If we consider the soil particle, if the rearrange the voids, it's become a capillary tube. Means these voids above another voids, means these voids will produce a capillary tube. Okay. Now, due to the surface tension of the water particle, that is the molecular attraction of the surface particles and the molecular attraction of the water body particle, the water try to ups the groundwater try to up the voids produce a capillary tube, because if we rearrange or connected the volume, connected the area of the voids, it's become a capillary tube, and due to the surface tension, the water try to up, and if the water try to up due to the capillary action, the surface of the water become fully saturated or partially saturated, and this is the main phenomena of capillary rise of water in a groundwater. Now I discuss in Hindi because most of my students told me that sir, if you discuss some Hindi, then it will be easy to understand. Okay, देखो soil consists of voids and voids and solid particle. voids और solid particle लेके एक soil होता है, soil का combination. Now वो जो voids है, particle का जो voids है, उसको अगर rearrange करेंगे तो एक capillary tube जैसा आएगा, एक tube. Now due to the surface tension क्या होता है? Surface tension is a property of the water. ये एक वाटर का प्रॉपर्टी है, ठीक है. जो वाटर का आउटर एग्जिस्ट अ फिल्म एट द आउटर पेरिफेरी ऑफ द वाटर पार्टिकल, एंड इट कॉन्ट्रैक्टेड, मतलब ये जो टोटल वॉल्यूम है उसको रिड्यूस करके एक स्फेरिकल शेप में, एक ड्यू टू द टेंशन के वजह से इसको अपलिफ्ट करता है. दैट इज द सरफेस टेंशन. मतलब जो ग्राउंड वाटर ड्यू टू द सरफेस टेंशन थ्रू द कैपिलरी, मतलब थ्रू द वॉइड्स ये अपवर्ड जाएगा, एंड दैट केस इज कॉल्ड द कैपिलरी एक्शन ऑफ अ सॉइल पार्टिकल. और जब वाटर कैपिलरी एक्शन के वजह से अप होगा तो ये बीच में जो सॉइल है ये फुल्ली सैचुरेटेड होगा व पार्शियली सैचुरेटेड होगा. Understand? Now our main purpose is to find out the height of the capillary. Okay, to find out the height of the capillary. Now, this is a groundwater level. We all know, being a civil engineer, we know that the certain depth we find out our groundwater table, and we discuss about the capillary. We consider this a capillary tube, means the voids are connected, and due to the surface tension, the capillary action, the water goes to upward. Now HC is the height of the capillary rise, and TS is the surface tension, because the upper meniscus of the water has become a curve, and the force will be at we consider the Ts is the force, tension force, surface tension force. Now our main task is to find out HC, height of the capillary rise. Now in my Google Classroom, I already gave the all notes. Now again we discuss. Now the volume of the capillary water, volume of 4 d square okay, this area into height, that is HC. Okay, now the weight of the capillary water, weight of capillary water means into unit weight of water, that is pi by 4 d square into HC into gamma W, that is the unit weight of water. If we multiply the unit weight of water with volume, then we can easily get the weight of the water. Now the Ts, the vertical, okay, another thing, this is alpha. Okay, the angle with the capillary tube is alpha. Now the vertical component of Ts will balance the weight of the water, that is upward, and self weight of the water downward, means the vertical component, and the vertical component, if we Ts pi d cos alpha, that is the vertical component. Vertical component of Ts, that is Ts pi d cos alpha. Clear? Now what I say, the upward and downward force, it will equal the upward and downward force. The upward force is Ts pi d cos alpha and downward force is the self weight of the water. Then we can write Ts pi d cos alpha equals to pi by 4 d square Hc gamma W. Clear? Now if the surface is clean and wet, then we can consider alpha equals to 0. In my notes I already given this data. Okay, then AC equals to 4 T S cos alpha by D gamma W pi D S gamma W. Okay, now Ts is the surface tension and the value is 75.6 into 10 to the power minus 6. Okay? Because the surface tension value is always same. Now another thing, that is kilonewton per centimeter, that is 10 to the power minus 8, and gamma W is the unit weight of water, and gamma W equals to 9.8 into 10 to the power into centimeter. Now all things I convert into centimeter. Now if and the alpha is 0 consider, because I consider that the capillary tube, the surface of the capillary tube is clean and it's wet. Okay. Now if we put the value in this equation, then we get a value of AC, and the value of AC equals to 0.3084 by D. Okay, in centimeter. You can try, okay? You can try in your copy. Just put the value of TS and all data, and you can easily find out AC equals to means height of the capillary. We can easily find out that is 0.3084 by D, and D is the diameter of the capillary tube. And another formula, actually in competitive exam or GATE or IES, they use some tricks. Okay, they use some tricks. They not follow the normal way, normal formula, normal way.